Hello students, this class we are going to discuss about the potential energy concept, most important concept for the competitive examination. The potential energy we are indicating with the letter U. We are indicating with the letter U, that is U. It is one of the scalar value, that is U. Now what we are learning in this topic. Before that, already in the previous class we learned about electric potential concept. So what is electric potential concept? Just I am revising here. We taken a charge, that is capital Q, called a source charge. Due to this source charge, at different points from the source charge, different potential values will be exist. This potential at points like A point, B point, C point, we calculated by taking a test charge at infinite. We have taken the test charge at infinite. By moving the test charge from infinite to the particular point, that means from infinite to any point, that is up to the A point, like up to the A point. Next, from the infinite to the B point, and from the infinite to the A point, C point, B point, A point. So how much work you are doing, that much potential is there at that point, we can able to explain. The work done to bring the charge from infinite to C point, that is nothing but potential at C point we are calling. The work done to bring the charge from infinite to the B point called as potential at B point. The work done to bring the charge from infinite to the A point is called potential at A point. In this case, already we discussed electric field always exists from the positive charge and start from positive, and it is going to be in this direction. Electric potential start from positive, it is going to be oriented like this. So that means you are doing all the work against the electric field. That's why you have to do the work, because positive repels. So against the repulsion force, you are moving the charge. That's why you have to do the work. So in this case, what I am discussing here, work done. Potential is nothing but we discussed work done per unit test charge. This is the base we discussed, and the derivation of this one we derived 1 by 4 pi epsilon naught into one of the concept we can write as, that is capital Q. Okay, that is capital Q by R is the formula we got. If small r is the distance of that point which you chosen, R is the point of distance. If A is the point if you chosen, RA is the distance. B is the point if you chosen, RB is the distance. C is the point if you chosen, RC is the distance. So potential, okay, due to any source charge is equal to potential always depends on the source charge and distance of that point where you are calculating the potential. Now what is potential energy concept? Here only one point you keep it in mind. Potential always depends on only single source charge. This is important here, right? Potential is proportional to source charge. That source charge will get energy. Okay, that energy we are calling as potential energy concept. So in this case, energy when it is going to get. Now we can write the potential energy formula from this discussed formula. V is equal to W by Q naught. What is potential energy? Any energy in the universe is in the form of work done. So the work done gives the concept of energy. What factor this energy of a given charges or depends, that we will discuss after the completion of the formula expression. So in this case, V is equal to W by work done per unit charge is called as potential. From this, the work done will be equivalent to energy. So from this formula, W is equal to, from this formula, W is equal to potential into Q naught we can write. So electrical potential into charge. The electrical potential mainly depends on the source charge Q and into the whatever the charge you taken into consideration in the system. Along with that, total will becomes, that means potential, electric potential to the source charge into charge gives the work done concept. This work done will be stored in the form of energy, that means called as potential energy concept, that we are indicating with this work done we are indicating with the letter U. U is equal to, we can write V into Q naught. So what is V here? Already you know that U is equal to, V is potential. Already we discussed the potential equation, that is 1 by 4 pi epsilon naught into, that is capital Q by small r into Q naught. So I can write the expression of this one is equal to simply 1 by 4 pi epsilon naught, nothing but K into capital Q small q naught by R is a formula. So if you observe here, this U, whatever the potential energy is there, that is proportional to product of the two charges, Q into Q naught. Not only that one, it also inversely to distance. Potential also inversely to distance, and potential energy also inversely to the distance. There is no change. But what is the difference in the potential and potential energy? Potential only depends on the single source charge, but potential energy depends on single source charge as well as the other charge which is surrounded by it. That means the energy, potential energy of a charges depends on system of charges. System of charges means minimum two charges required to explain the potential energy concept here. Single charge, we are not going to explain the potential energy concept. If you want to explain, you have to take the another charge as a unit charge. That is also you have to take into consideration, like as you are looking like this, Q into, okay, capital Q into Q naught. So that means energy concept always we are expressing the system of charges. Minimum system of charges we can take it as two charges, and more than two charges, 3, 4, 5, like that, so on. Infinite number of system of charges also we can able to take. So what is the energy of the system? To understand this one very clearly, so if we come across okay, some examples we'll give. Now to understand the potential energy of the concept very, okay, most deeply, you can come across one of the example, because understanding is most important. Here one person is there, and like imagine like a charge. Now this charge having potential, the person having potential to pull this block. One of the block you can see he's pulling with the thread, right? So how much potential he is having due to single, that is equal to v is equal to k into q by r is the potential of this person. Now in this case it is not sufficient, single person can't pull this block, right? So minimum required, two persons are required here. So that means in this case, if you see the second diagram, in this case we have two persons are there. This is called system of charges concept. The main person, if you say Q, single charge Q, have a potential. He is having potential, but he can't pull that one. He can't do the work. So work done, if you want to do, if you want to explain the person, okay, energy or charge energy, there must be a work done. Work done means there must be a system of charges. Here two persons are there, both are pulling the block, both are pulling the block. In this case there is a work done takes place. That work done is equal to, if you say person charge is q like, and another person charge is, you could take it as small q like, then work done is equal to, according to concept, this person having potential, that is v into, due to addition of this another person he got the energy. That energy only we are calculating in terms of work done as a potential energy concept. So that means V into Q I can write. So in this case, what is V? Already we written here, K into capital Q by R into small q. What is small q here? Charge of the another person, right? So this work done will be stored in the form of energy as a potential energy of the system of two charges. In the case of two persons, if together they are doing the work, that work will be nothing but equivalent to energy. In the case of person, if you imagine the charges, both together, okay, perform some work done electrically, that is called electrical potential concept. That is, electrical potential is nothing but K into Q into capital Q into small q by R. Here our important point of concentration is this is. So potential energy always depends on system of charges, that is, one is source charge, that is capital Q source, second one is additional charge, that is called supporting charge, like so capital Q into small q. Now I can pull this block, not only 2%, 3, 4, 5, so on, number of persons also you can pull. You can see that this is number of persons are pulling the same block. So that means in this case number of charges I can say here, that is capital Q into, okay, capital Q and small q, and you can write as q1, q2, so on, like that we can write. So that means in this case the work done to pull this one is equal to nothing but we can write as K into Q into, that means combination of system of charges. If we take on the two persons, we are getting Q and Q, like that. If we take on the number of charges, then we have a lot of combination of the, okay, charges. These two becomes as a one combination, these two persons acts like another combination, these two like another combination, so like that these two persons acts like another combination. So combination of number of charges will be there. So basing on this one I can write here, okay, so 1 2 3 4 5 totally. Capital Q is one of the charge. If you say according to that one, I can write the formula here, like this total energy of the system is equal to, we can write as due to capital Q, and Q1 is one energy, okay, and that is Q into small q, another one, that is U, okay, into, that is Q into Q1, like that we can so on, we can write. That means we can write the factorial times of, that is factorial value of q. So how many combinations you will get between the capital Q, Q1, Q2, Q3, Q4, Q5? Total 6 members are there. The factorial, okay, combinations, how many you are going to get, that many work dones will be present here in the case of system of charges. If we take on the only two charges, only we have a combination of two system of charges. See here, first we'll go to the formula based and just you try to understand here what we are understanding. Single charge, we are unable to do any perform work here. By imagining the test charge, you can able to explain the work. So this person having potential, the potential will be when added by another person, that becomes into energy constant, that is potential into charge, nothing but energy. Potential depends on source charge and energy due to addition of another multiple charge. So how many number of multiple charges are present in the system, that much energy of the system of charges will be changes. So this total energy of the system of charges we are calculating by taking the number of combination of charges, that is factorial number of charges we are going to take in this to calculate. Now we are going to understand the different types of, okay, system of charges concept. Now formula based we are going to discuss now. Now we will discuss the potential energy due to system of different system of charges. First, minimum, how many charge system we can take? Two charge system we can take. So consider the two charge system here. I have taken two, okay, charge, two charges I taken. This is way we taken the two charges, like one charge is nothing but take it as q1, second charge is nothing but take it as q2, and both are separated by a certain distance. The distance of separation between them is given as r. Now the energy of the system of these two charge system we can write as u1 2. That means between one charge, second charge is equal to u12 is equal to, according to formula, what is the formula? 1 by 4 pi epsilon naught into one charge, that is q1, second charge q2, by distance between them, that is, this is a formula for system of two charges. If with respect to 1 to 2, if you want to calculate the energy due to second to 1, that you can write as u2 to 1 is equal to 1 by 4 pi epsilon naught, we can write as q2 q1 by r. If you take on q1 q2 or q2 q1, both are appears to be similar, so u12 is equal to u21. So that means in this case, how many combinations of the energy of the system of charges you got? Only one. That is, both formulas are similar, that means only we got one energy, okay, combination of the two system of charges we got. That is important for us. Suppose if you taken the, in the place of two charge system, if you taken the three charge system, if you taken in that cases, so totally three charges if you taken, which are arranged in the form of equilateral triangle. If you say, if you want to say equilateral triangle, three charges are taken, the three charges are kept as you are looking like this. This is second charge, this is third charge. Three charges are taken here. These three charges are kept at the three corners of the equilateral triangle. Now this becomes one of the system of charges. All charges are you taken. If you want to take this one as q1, this one as q2, this one as q3, and all are separated by distance of a, if you say equilateral triangle. In this case, what is the energy of the system of these charges? If you want to calculate the potential energy of this system of charges, in this case, first the how many charges are there? Three charges are there. If you observe this one, all okay, minimum okay, energy concept we are expressing using two charges. So q1 q2 creates one energy concept, that means there is a energy, potential energy situated between the first charge and second charge, that is u12, plus, because energy is a scalar quantity, so you have to take the combination of energy of the system here, and second charge, third charge also forms like another system, that is energy combination of 2 and 3, plus third one, okay, that means third charge, first charge, there is a energy between these two, that is 1. So can you take any other combinations? Means you can check it that you can't take any combination. 1 3 is over, 1 2 is over, 2 3 is over. So the maximum possibility of energy combinations we can take for the system of three charges equal to how many? 3. That is U12 plus U23 plus U13 or U31. So if you want to write the formula for each one, U12 formula. What is U12 formula? 1 by 4 pi epsilon naught I am writing as K into charge Q1, that is Q2, by distance. That is, what is the distance? That is distance between the two charges, that is nothing but A. So directly I can take it as A. This is first. Second, similarly, U, okay, 2, 3. What is U23? U23 is equal to K into second charge, third charge by distance between them. That is also A only. Now, what is the distance between? Okay, that means U13, 1 and 3. System of energy between the 1 and 3 is equal to K into first charge, third charge by R. So, the total energy of the system is equal to, we can write as U is equal to U12 plus U23 plus U31. This is called energy of the system of potential energy due to system of charges we are calling. In the case of two system, this is the formula. In the case of three charges, this is the formula. Now, how we are applying this one into the case of while solving the problem, that is important for us. Now here concept is, suppose this charge is Q2 charge is not there, imagine. In the case of two system of charges, this Q2 is not present, you imagine. This Q2 is not there, suppose. Then the question is, if I taken the Q2 at infinity, if the Q2 is infinity, so how much work I have to do to bring this Q2 from infinite to here at this point? So how much work you have to do? How much? If you imagine that this Q2 is already here, that means how much energy is associated, that much equivalent work you have to do. That means the energy between U1 to 2 must be equal to work done to bring the charge from infinity to that point. So that means simply I can write here, the work done is equal to nothing but U1, 2. The energy of the system of two charges, that must be exactly equivalent to bring the charge from infinite to that point. How much work you have to do is equal to energy of the system. So final condition of the energy, you can take it as work done to bring the charge from infinity. Like that we can explain. In the case of three charge system, three charge system, suppose Q1 is not there. Imagine that the Q1 is at infinity. Now you want to bring this Q1 from infinite to this point. So if you want to bring the charge from infinite to that point, how much work you have to do? In this case, you have to calculate the energy of the system here. Okay, when you calculate the energy of the system, how much work you have to do, to bring the charge from here to here. That is equal to energy of the system, because you have to bring this Q3 repels this Q1, Q2 also repels this Q1, so both are repels each other. So combination of both repulsion, you have to do the work. So in this case, the energy of the system, what is the energy of the system? That is nothing but U. The total energy of the system is equal to U if we say, and the work done is equal to U, W if we say. So in this case, the work done is equal to energy of the system, it becomes equal. So this concept is most important. So concept is, if you want to bring the charges infinite to here, that means like this also I can able to explain three charges system. If you want to keep the three charges as an equivalent triangle, how much work you have to do? This is the work here. Otherwise, already three charges are there. I want to separate them and I want to make it to infinite. How much work you have to do? This is the work done here. So one of the charge is there, not present at the corner. Okay, if you want to bring it, how much energy of the system is there? That much work you have to do. Bring the charge from infinite to that point. So this is the concept. To combine the charges or separate the charges, the work done will be remain same. That depends on the system of charges concept here. So next we are going to discuss about the four charge system like that in the coming topic. Now consider the four charge system. Here four charges are I taken as Q1 and Q2, Q3, Q4. In this case, what is the energy of the system of these four charges? The energy of the system of these four charges U is equal to how many number of combination of energies we can take it. There is a combination between 1 and 2, so that is U12. There is a combination between 2 and 3, that I can write as U2 2 to 3, plus combination of 3 and 4, that is U4, 3 to 4, plus combination of 4 and 1, I can write as 4 to 1. And we have, if you observe this one, there is a cross charges also is there. They are interaction. We can, because we can draw a line from Q1 to Q3. So there is this also acts like one system of charge. Okay, so I can write as U1 to 3. Next, the 2 and 4 also acts like a one system of charges. That means U2 to 4. So these are the combination of energies of the system of these four charges. If you observe how many combinations we are getting, 1, 2, 3, 4, 5, 6 total combinations. So this system contains 6 combination of energy of the charge part. Okay, potential energy of the combination system it is having. So here what our concept is, whenever as the number of charges are increasing, the group of combination of charges also increases, and energy of the system also increases. It is similar like if you are if anyone protecting single person, energy is less, and if another person is added, energy is going to be increased. More the number of people are behind, more the energy will be there. So potential energy of the system is depends on number of charge system. More the number of charge system, more the combination of charges will get, more the energy of the system will be there. So here also same thing. If you want to bring any charge from infinite, okay, to the any point of the system, how much work you have to do? This is the U is the energy of the system. If we say the work done must be equal to energy of the system, it is equal. And it is also depends on the point where you are choosing also. If the system charge, where the charge is present according to formula, at that point if you are bringing, so the same energy of the system we are taking. Suppose if the point is varies, then energy of the system of the combinations also changes according to the distance of the point, but concept is same. Total energy of the system at a point is equal to work done to bring the charge from infinite to that point. That is important to understand this concept. So now if you taken the okay, not four charges, 5, 6, 7 like that, multiple, as the number of charges increases, how many number of combinations you are going to get? The combinations we are going to get already just we discussed. When you taken the 2 charge system, we got 1 combination. And when you taken the 3 charge system in the equilateral triangle, we got 3 combinations. When you taken the 4 charge system, we got 6 combinations. So if you taken n charges of the system of charges, when you taken n system of charges, in this case, how many combinations of energies you are going to get? The energy of the total system is equal to, that is nothing but n into n minus 1 by 2 combination of energy of the system you are going to get. So you take just formula because we can apply later. So what is the formula for this one? N into n minus 1 by 2. So if you want to check it, that you can check it, you can verify using this way. So if n is equal to 1, n is equal to 1. So what is the meaning of n is equal to 1? N is equal to 1 means, so only one charge system is there. That is 1 into, according to formula, what you will get? 1 into 1 minus 1 is 0 by 2, nothing but is equal to 0. You are not getting any energy of the system because single charge, source charge required another charge combination to explain the concept of energy. Suppose if n value is equal to 2 system of charges if you take 2, n value put the 2, that is 2 into 2 minus 1, that is 1 by 2 you get, that is equal to 2 to get cancelled, you will get 1. So already we discussed, when you take on the 2 charge system, there is a energy bonding between the 2 charges, u1 to 2, u1 to 2 is equal to u2 to 1. So both are same values, that's why only one combination of energy of the system you will get, either if you calculate from 1 to 2 or 2 to 1. Suppose if n value is equal to 3, already this is also we done, 3 combinations we got, put the value here, how much you will get? 3 into n value 3 minus 1, that is nothing but 2 you will get by 2. So 2 to get cancelled, how much you are going to get? 3. Like this. Suppose if you come across a case of 4 charge system, if n is equal to 4, in this case, as you are looking on the board, n is equal to 4 if you take, and in this case, what are the combinations? 4 into 4 minus 1, how much? 3 by 2 you will get, that is 2 to get cancelled, 2 3 6. Total 6 combinations you are going to get. So you can check this 1 2 3 4 5 6. So when you take in the n value is equal to 4, that means 4 charge system, how many combinations of energies you are going to get? 6. So like this, if you take in the n charge system, how many combinations you are going to get? N into n minus 1 by 2. This formula is most important to understand the number of combination of energy system of a group of charges. We can able to explain. Now we'll discuss how this energy of the system is measured in terms of energy of a system is equal to nothing but work done. This work done is equal to nothing but potential into charge. So already in the previous classes we learned. So in this case, what is potential? Potential we are measuring in terms of volts, volt into charge we are measuring in terms of coulomb. So energy of a system can be measured in terms of volt into coulomb is 1 unit, and energy is one of the nothing but work done. Work done nothing but another unit is joules. So these are the two combinations of units we can use it. So energy can be measured in terms of volt coulomb or joules also we can able to explain. In this case we have one conversion is there. Okay, one, that means this is the okay energy due to charge called as potential energy, also called as electrical potential energy. That electrical potential energy we are measuring in terms of volt and charge. So one, okay, unit of that means 1 electron volt. That means 1 electron means, suppose if you are taking the charge of 1 electron, how much energy it is having? That is nothing but 1 electron volt we are calling, because volt is the voltage, this is volt, and q is the charge. I take an electron is the charge. If you say okay, that energy is nothing but electrical potential energy. So that electrical potential energy we are measuring in terms of electron volts, that is ev we are calling. 1 electron volt is equal to how many joules? So in this case 1 electron volt is equal to simply 1 into, what is the charge of the electron? 1.6 into 10 power minus 19 joules. That is nothing but we can write as simply this is the value of this. 1 electron volt equal to 1.6 into 10 power minus 19 joules. It is equivalent. So this formula we are going to use for different problem sake in the conversions of electrical energy to mechanical energy concept. That means 1 joule equal to how much electrical potential energy value equal. 1 joule is equal to, that is nothing but 1 by 1.6 into 10 power minus 19 value. This is equal to electron volt value. 1 joule equal to how much? Electrical volt equal, that is nothing but, so 1 by 1.6 into 10 power minus 19 electron volt value, it is equal. So like this you need to able to apply the values to solve the problems.